So let's take a look at how you've done on these. So the 7x over 8 plus 5x over 12. What's our common denominator going to be? 24, very good. Since it's just 8 and 12, we don't have to do a whole lot special. What's this going to end up being? 21x, good. 8 times 3 to make 24, so 7x times 3 makes 21x. What will this be? 10x, good. 12 times 2 to make 24, so 5x times 2 is 10x. And we're adding, so 21x plus 10x is 31x over 24. Very good. Down here, 8x squared over 9y divided by 4x over 15y to the fourth. Well, the first thing we have to do is, perfect, we're going to flip this over, we're going to multiply by the reciprocal. So this will be 15y to the fourth over 4x.
Now, once you reduce it right there.
You could reduce it right there, or I usually pull out the numbers separately to make it easier. If I have the numbers by themselves, it's easier for me to see what I can reduce by. What can I cross cancel here?
4 and 8.
4 and 8 both divide by 4.
So 1 and 2.
Give me 1 and 2.
And 9 and 15 both divide by 3.
9 and 15 both divide by 3 to give me
3
3 and
5.
5. Good. So that's a 5. So then we have 2 times 5 is 10. 3 times 1 is 3. Do we reduce that to 3 and 1/3? No, we do not. Yeah, we have the variables, so we don't know whether that can be reduced or not, so we're going to leave it. Now we're going to take our variables out. What do we have on top? We have x squared and y to the fourth. On bottom, y and x. Now I'm going to go ahead and I'm going to do them in order, so I'm going to do the x first. Where's the x going to go in our answer? On top, what power? Just x. It would be, this is a 2 and a 1, so 2 minus 1 is 1. So x to the 1 is just x. Y goes top or bottom? It's on top, because the bigger power is the y to the fourth. It's on top. And it'll be y to the third, because this is 1, so 4 minus 1 is 3. So y to the third. So 10x y to the third over 3. Any questions? Let's have you try one here then that's something like this. 7 over 12x minus 5 over 8x squared. I'm going to pause for a second. Let you try that one. Okay, so we're going to set this up. 7 over 12x minus 5 over 8x squared. What is our least common denominator going to be? 24x squared. Very good. It's always the larger power of the variable. So what do we have to multiply 12 by to make 24x squared? 2x. So 7 times 2x makes 14x. Now, if you're struggling to see where this 2x comes from, you can just take 24x squared and divide by the 12x. And you're going to get 2x. So here, what do we multiply the 8x squared by to make 24x squared? Just 3. Right? We already have the x squared, so we don't need to adjust the x. So 5 times 3 is 15. Now that we have a common denominator, we can go ahead and subtract. 14x minus 15 is 14x minus 15, or negative 15 plus 14x if you want, over 24x squared. Since this is a 14x and this is a 15, I cannot combine them completely. It's just 14x minus 15. Any questions? Okay. Well, some other things that we worked with. We worked with reducing fractions, just to make sure we're good with that. We might have something like 28 x to the 8th, y to the 5th, z over 21 w squared x to the 10th y. What does that reduce to? Give you guys a second to reduce. So again, just like any other one, we're going to pull out the numbers and reduce them. What can 28 and 21 both be divided by? 7. So that's going to give us 4 over 3. Now for the variables, which one do we start with? W. What happens with the W? Just stays on bottom as W squared. Good. X. First of all, top or bottom? Bottom, because the bigger power is the 10s on bottom, and it's going to be squared. 10 minus 8 is 2. How about the Y? Top. It's 5 and 1, so the bigger one's on top, and it's going to be 4. And then Z on top. And that's it. We reduced it. Now we're working with just fractions here. No whole numbers or anything mixed in with it. Because when we have variables in it especially, we can only have fractions. We cannot have mixed numbers with variables in them. So the good news is we're going to move away from having variables in our fractions because we're going to start working with mixed numbers a little bit. So to review our mixed numbers, a couple of you are looking scared at me like you don't trust me. Something like this, 32/5, is what we refer to as an improper fraction. It was considered improper because we don't like having the numerator larger than the denominator. There's nothing wrong with it. The word improper is kind of a poor name because improper implies incorrect or wrong. There's nothing wrong with it. There are times when we prefer to have numbers in that form, but it's considered bad grammar to leave it that way, kind of like, having the variables out of order and stuff like that. So to change this from an improper fraction into what we referred to as a mixed number. Remember, a mixed number had fractions in it, but also whole numbers. We needed to figure out how many whole objects we can get out of this. The 5 is telling us that each whole object contains 5 pieces. So what we're trying to do here is figure out how many sets of 5 I can take out of that. It's basically a division with a remainder. Now, a lot of you have already said the answer. You've got it right. 5 goes into 32 how many times? 6. 6 times 5 is 30. What that's telling us is those 6 whole objects use up 30 pieces. And what's left is 2 pieces, so that's 2/5. So this is 6 and 2/5. We'll also do something a little bit less easy to do. Like 116 over 13, and let's reduce that to a mixed number. I'll give you a second before I do it. So 13 doesn't go into 1, doesn't go into 11. It goes into 116 8 times, which is 104 with 12 left over. So it's 8 and 12 thirteenths. Any questions? Try this one. Some of you are looking confused. That's a good thing. If I reduce that, what do I get? 47x over 8. There's a variable in it. We cannot reduce it to a mixed number. I know I'm not a very nice person.
So you're really good at throwing.
I'm a math teacher. I'm not supposed to be a nice guy. Remember that. You cannot reduce that. The second there are variables in it, we cannot reduce it to a mixed number. We have no idea what that x stands for. We don't even know if this is an improper fraction. That x might be 0.1, so that could be only like a 4.7 over 8. We don't know if it's improper or not. So we cannot reduce that to a mixed number. Okay, I'll give you one that's actually possible. Try that one. So 328 divided by 31. 31 does not go into 3, but it does go into 32 once. With 1 left over, we bring down the 8. Does 31 go into 18? No, so it's 18 over 31. What am I forgetting? I put a 0 there. We bring down the 8. That means something's got to go above the 8. 31 wouldn't go in there, so it has to be a 0. So 10 and 18 over 31. I probably won't be quite that mean to you on a test, just so you know, but it's good to know how to do it. Speaking of tests, by the way, I don't know if you've noticed in my math lab or not, but your test 2 is scheduled for 1 week from today. So next week, Thursday. It's okay, you'll live. 1 week from today, so next week, Thursday, is test 2.
Is it going to be the same length as?
Pretty much. Actually, this one's a little bit longer, but you'll do fine. No easy Thursday, no. So anyway, oh, you only work for 2 hours? That's not bad. That's not bad. Okay. So we were working with just fractions last class. And I want to throw in here what happens if we have, we were dealing with things like, 1/2 plus, I don't know, 1/6. And we had to find that common denominator and add them together. The common denominator here is going to be 6. So the 1/6 doesn't change. This is going to become 3/6. We add 3/6 plus 1/6 is 4/6. Are we all done? No. We can reduce that. Both of those can be reduced by 2. So we get 2/3. Even though we use the smallest common denominator, we could still reduce when we're done. That does happen actually quite a bit with addition and subtraction. But what I want to look at today is, or to start off today I should say, is what if one of those is a whole number? What if instead of 1/2 plus 1/6, what if it was 4 plus 1/6? Yeah, it's actually quite simple. It is just 4 and 1/6. If I were to set this up, this is like 4 and 0/6 or whatever. There's really nothing to combine. The whole numbers and the fractions just kind of go together. We'll look at multiplying here. What if I had 5 times 2/3? Well, I make my 5 into a fraction by doing what? 5 over 1. So now it's 5 times 2, combining the counts, is 10. Then combining the names, 1 times 3 is 3. Now 10/3 can be reduced. 10 divided by 3, I get 3, which is 9 with 1 left over. 3 and 1/3. Or if I had something like 3/5 times 25. How do I multiply that? I make that 25 over 1. Now, even though that 25 was a whole number, I can still cross cancel. I have 5 and 25 cross cancel. They both divide by 5 to give me 1 and 5. So now I have 3 times 5 is 15. 1 times 1 is 1, so that's just 15 over 1 or 15.
Can we do another one like that?
Yep. So 5/6 times 8. Well, the 8 becomes 8 over 1. Then what? We're going to cross cancel the 6 and the 8 by both divide by 2 to give me 3 and 4. So 5 times 4, 20. 3 times 1 is 3. 20 divided by 3 is going to be 6 and 2/3. In your notes, I want you to do 2/3 times 9 for me. So 9 over 1, then what? Reduce. 3 and 9 divide by 3. Give me 1 and 3. So then 2 times 3. 2 times 3 is 6. 1 times 1 is 1. So yeah, it is just 6. 6 over 1 is just 6. How about dividing? Let's say we had 8 divided by 3/4. I'm going to make this 8 over 1, right? Can I cross cancel the 8 and 4? Yeah, right now we can't because it's still division. But we have to turn it into multiplication. Yeah, there we go. Multiply by the reciprocal. So the 8 over 1 does not change, but instead of dividing by 3/4, it becomes times 4 over 3. Now that it's multiplication, we could cross cancel. Unfortunately, right now, there's nothing to cross cancel. So we're just going to multiply. 8 times 4 is 32. 1 times 3 is 3. So 32 divided by 3 is 10 and 2/3. I realize most of you can look at 32 over 3 and see that it's 10 and 2/3, but I like to go through this process just in case you don't quite see it. So let's try another one of those. Let's do 12 divided by, what do I want to put in here? 6/7. Try that one in your notes quick. So it becomes 12 over 1. Then what? So yeah, the 12 over 1 stays the same, but it's going to become times 7 over 6. And then reduce the 12 and 6. 1 and 2. And then 2 times 7 is 14. 1 times 1 is 1, so 14 over 1 is just 14. Not so bad? Better than a sharp stick in the eye? Okay. Any questions? Okay. So we've reviewed a little bit of adding our fractions, finding the common denominator. So now we're going to step up. What if it is a mixed number? What if it is something like 4 and 2/3 plus 7 and 4/5? Now let's not do 4/5. Let's do 1/5 for now. So we've got to write this. I like to do my addition and subtraction vertically, so I'm going to write it vertically. You'll notice that when I set this up, I line up my fractions at the end of the number just like they're the last digit of the number, because that's actually all they are. Is a fraction is nothing more than the last digit at the end of a number. Now I do still need a common denominator, and some textbooks don't do this, but I always rewrite my whole number just so I don't lose track of it. What is my common denominator going to be between 3 and 5? 15 is my least common denominator, least common multiple. So what did I multiply the 3 by to make 15? 5. So the 2 has to be multiplied by 5 to make 10. Good. What did I multiply by 5 by to make 15? 3. So I have to multiply my 1 by 3 to make 3. Now, just like any other addition, I start at the right and I work my way back to the left. So I'm going to add my fractions first. 10/15 plus 3/15 is 13/15. Then 4 plus 7 is 11. Good.
Why do you have to do the fractions first?
You'll see as it coming up here. In a couple examples, you'll see. In your notes, I'm going to have you try to add those two quick. So I'll set this up vertically again. I'll rewrite it so I can get a common denominator in here. What's my common denominator going to be? 12. So the 5/12 doesn't have to change. This is going to become how many 12s? 3. 4 times 3 to make 12, so 1 times 3 makes 3. Now we start on the right again. We always add right to left. 3/12 plus 5/12 is 8/12. Now before we move on, what can we do to that? Reduce it to 2/3. Very good. Now we've got 9 plus 16 is, or 9 plus 6, sorry. 9 plus 6 is 15. 9 plus 6 is 15, so 5 carry the 1. 1 plus 1 is 2 plus 2 is 4. So 45 and 2/3.
Okay, my question is, when you reduce that 8/12, wouldn't there be another one to add to the whole?
No, because 8/12 is less than 1. What you're thinking about is this next example. Something like this. So 8 and 5, 6. 5 and 3/8. And we're adding. Once again, we need a common denominator. Between 6 and 8, the common denominator will be, we could multiply them. 6 times 8 is 48, but there's one smaller. 24. We could use the 48, it would work fine, but we'd have to reduce at the end. So anyway, what's this one going to become? Perfect. 6 times 4 is 24, so 5 times 4 is 20. Good. This one will become 9. 8 times 3 to make 24. 3 times 3 to make 9. Now we've always said we start on the right and we work back to the left. Because here we have 20 24ths plus 9 24ths makes 29 24ths. Now this time that is bigger than 1. That splits up into 1 and 5 24ths. So we keep the 5 24ths and we carry the 1. 1 and 8 makes 9 plus 5 is 14. Let's try another example similar to that. Oops, sorry. Well, this was 1 and 5 24ths, so we carried the 1 and kept the 5 24ths. So we have 32 and 3/4 and 19 and 4/5. We need a common denominator, which is going to be 20. This is going to be 15. 4 times 5 makes 20. 3 times 5 makes 15. This is going to be 16. 5 times 4 to make 20, so 4 times 4 to make 16. And now, again, we start on the right, work our way back to the left. 15 20ths plus 16 20ths is 31 20ths, which can split into 1 and 11 20ths. If you need to, you can go off to the side, do 31 divided by 20 is 1 with 11 left over. So now we're going to keep the 11 20ths and carry the 1. 1 and 2 makes 3, plus 9 is 12, so 2, carry the 1. 1 and 3 is 4, plus 1 is 5. 52 and 11 20ths. I'm going to give you one to try in your seats. Oh, what do I want to put in here? Try that one quick. We need a common denominator, which is going to be 63. A little hint, 7 is prime. Whenever one of your denominators is prime, the common denominator will be just multiplying the two of them together. Since 7 cannot be split into anything else, and the only exception would be if 7 went into 9 and it doesn't. So since 7 is prime and it does not go into the other denominator, you have to multiply them together. What's this going to be? 45. 7 times 9 is 63. 5 times 9 is 45. What'll this be? This one's 35. 9 times 7 is 63. 5 times 7 is 35. So we go to add. 45 plus 35 is 80 63rds, which splits down into 1 and 17 over 63, which means we will keep 17 63rds and carry the 1. 1 and 8, 9 plus 4, 13. 3, carry the 1. 1 and 1, 2 plus 2 is 4. How many of you had 43 and 17 63rds? Good deal. Anybody really struggling and needs to see another example of that? Good. So now, let's go back a step. We had stuff like 12 plus 2/3. Technically, when we looked at that, we just combined the whole number and the fraction to make 12 and 2/3. But technically what we're doing there is this. That's 12 and 0/3. There are no thirds, no pieces left over. Plus the 2/3. 0 and 2 make 2/3. And we have the 12. Now, I'm not going to do any more examples of that because I don't want to confuse you. But there is a reason for me showing that to you. Next, we're going to do subtraction. If you recall from subtraction, we have things like 3/4 minus 1/6. We do the same thing. I like to do my addition and subtraction vertically. We need a common denominator, which is 12. What's going to go here? 9. 4 times 3 to make 12. 3 times 3 is 9. What's going to go here? 2. 6 times 2 makes 12. 1 times 2 is 2. And we subtract. 9/12 minus 2/12. 7/12. Well, again, the goal of today is to move up to mixed numbers. So let's have 8 and 2/3 minus 6 and 1/5. Just like with addition, I line it up with that fraction becoming the last digit of my number. And just like addition, I need a common denominator, which is going to be 15. This is going to be 10. 3 times 5 is 15. 2 times 5 is 10. This is going to be 3. 5 times 3 to make 15. 1 times 3 is 3. So now, just like with whole numbers, we start on the right and work our way back to the left. 10 minus 3 is 7/15. 8 minus 6 is 2/15. Or 2, so 2 and 7/15. I don't know where that 15s came from. 2 and 7/15. So I'm going to have you guys try one in your notes. 9 and 3/4 minus 2 and 3/10. Try that one quick. We need common denominator, which will be 20. Very good. 40 would have also worked, but we'd have to do some reducing. What'll go here? 15. 4 times 5, so 3 times 5 does make 15. Here, 6. 10 times 2 make 20, so 3 times 2 makes 6. And we subtract. 15 20ths minus 6 20ths. 9 20ths. 9 minus 2? 7. So 7 and 9 20ths. Well, they don't always stay that simple either. We have ones like this. 9 1/4 minus 6 2/3. We need a common denominator, which is going to be 12. This one's going to become 3. 4 times 3, so 1 times 3 is 3. This is going to become 8. 3 times 4 to make 12, so 2 times 4 to give us 8. We go to subtract. 3/12 minus 8/12. We have an issue there. We can't subtract 8 from 3. Well, not without going negative. We don't want to do negatives in the middle of a number. Just like with whole numbers, we can borrow. We're going to borrow from the 9. This becomes an 8. Now what we're borrowing is 1. And that one whole object contains pieces. How do we know how many pieces? 12. The denominator tells us how many pieces. So we're going to add 12 pieces to the 3, makes 15 12ths. So now we subtract. 15 12ths minus 8 12ths is 7 12ths. 8 minus 6 is 2. Let's do at least a couple more examples of that. You okay? So 7 2/5 minus 2 5/8. So once again, we need common denominator. In this case, it's going to be 40. What's this going to become? 16. 5 times 8, so 2 times 8. What's this going to become? 25. 8 times 5, so 5 times 5. 16 minus 25? Can't do, got to borrow. So the 7 becomes a 6, and this is going to be 56. That one whole object contains 40 pieces, so we have to add 40 to get 56 40ths. And now 56 minus 25 is 31 40ths. 6 minus 2 is 4. So 4 and 31 40ths. Well, we're going to do some more examples of this, don't worry. But it is time for our break. It is 4:20, so let's come back at 4:30 and let's begin our second half of our lecture.